Hello everyone, and here is the explanation for the problem we did in class today. Before we start talking about this problem, this is a situation we see a lot, especially with cars. You know, when you buy a car right out of the dealers, as soon as you drive it out the dealer, already the car is depreciated. That means that its value, the money, the amount that you paid for it when you went to the dealer and bought it, once you drive it out the dealer, it's worth less immediately. And as time goes by, as years go by, if you buy a 2013, 2014 car, the worth of the car will depreciate as time passes by. So this is similar to a car situation where this guy, Tristan, buys a computer for $3,600. That's a very expensive computer. And for tax purposes, he declares a linear depreciation loss of value, which means it loses value over time, of $600 per year. Okay, $600 per year. Now it tells you let Y be the declared value of the computer after X years. So already this is telling you what your X-axis is going to represent and what your Y-axis is going to represent. So I'm just going to start trying to draw an X and Y axis so that we can plot some points. Here's my Y-axis. Here's my X and Y axis. Now for my X axis, the problem says that this is going to represent years. And it also says that my Y axis is going to represent the declared value of the computer after X years. So this is the declared value. Notice that this computer was bought for $3,600. So when was the value of this computer $3,600? The value of this computer was that amount at time 0, right here. So when X is 0, that's when you bought your computer. It was worth $3,600. And the problem tells you that this computer will lose value over time. It says it'll lose a value of $600 every year. So if this is year 1 on my X-axis, and this is year 2 and year 3 and year 4, this is what's going on. The computer was bought at a value of $3,600. By the time 1 year went by, I'm sorry, this isn't straight. The computer's value came down $600, so now it's worth $3,000 after 1 year. And I have a coordinate here. At 1 year, the computer's worth now is $600. $3,000, I'm sorry. Its value went down $600. Now, by year 2, the second year, since the computer loses a value of $600 every year, now my computer is worth $2,400. Okay? So I have another coordinate here. And as you can see, every time a year passes, I will depreciate my computer by $600. So that alone tells you that the $600 the problem is talking about, that represents your slope. Notice how we're falling 600 and running 1 year. And then we fall 600 again and run 1 year. and then you can fall 600 again and run 1 year. So this amount represents slope for this line. So your first question is, what is the slope of the line that models this depreciation? $600. That's your slope. Now notice that since this is loss of value, and if I were to plot, if I go down $600 more for the third year, I'd have a point here. Notice this line has what? Notice this line has a negative slope. So this slope here should be negative. The second question, find the y-intercept of the line. What is the y-intercept? They're asking you, where does this line crash with the y-axis? And if you notice, my starting point was the initial value of the computer, which was the buying price, which was $3,600. That's why I started off at x equal to 0. This is x equal to 0. The computer was worth $3,600. I bought it, and a year later, it was worth $3,000. So this is where this line crashes the y-axis at $3,600. So that means that this is your y-intercept. It's the coordinate 0, 3,600. I'm sorry, this goes here. 0, 3,600. That's your y-intercept. So far I have a slope of negative 600. I have a y-intercept at 0, 3,600. I have enough information for letter C. Now letter C asks you to write a linear equation in slope-intercept form to model the value of the computer over time. So this is the slope-intercept form, the general form, and we have slope and we have the y-intercept. So very simply, all we need to do is plug in the slope, which is negative 600x plus b, and b we said was $3,600. For letter D, they want to know what the value of the computer is after 4.5 years. So remember, your x-axis is the one that represents years. So this value, I'm going to plug in to x. Y is equal to negative 600 times 4.5 plus 3,600. And that comes out to, let me get my calculator. Here's the calculator. Let me put it up here. So we have 4.5 times 600. I have to do it like this since this calculator doesn't have negatives, I think. So I know I'm going to subtract $3,600. Or I'm going to subtract this amount from $3,600. So it's $3,600 minus $2,700, which equals $900. And that's your answer here. Okay, that's the worth of the computer after 4.5 years. So after 4 years, you paid $3,600, and 4.5 years later, this is what the computer is worth. And there you have it. I hope you understood this. If you didn't, go back, listen again, try to make some sense out of it. And good luck tomorrow on the test. Good night. God bless you.